Age, half-life, and immortality. Here's an interesting idea concerning two sets of numbers. One we'll call your age. Your age is just how old you are expressed in integer numbers like 1, 2, 3, etc. The other set we'll call your half-life. This set will be a set of rational diminishing numbers that is also a convergent set. Unlike your age set, which is divergent, they can be shown as follow. Your half-life: 1, 1 half, 1 fourth, 1 eighth, 1 16th, etc., going out to 0. The half-life set decreases by 1 half of the original number with every member added. But let's go back to your age set. It increases by integer values. So to show it, we have 1, 2, 3, 4, 5 out to infinity. That's your age. Now let's say at some point in the second set, how about 25, which is your real age and time? We could map the first set to the second. But I want to go further. Let us also define that the your age set is your real physical age with all the medical, biological implications that coinage means. The second set, your half-life, is the measure of how much the first set extends. Here we have an exquisite mapping of sets. As you age in life from, say, an arbitrary number, 25, in your age set, the second set, your half-life, is mapped to it. Here's an example of it. When you're 25, you map to 25. When you're 26, you map to 1 half. When you're 27, you map to 1 fourth. When you're 28, you map to 1 eighth. When you're 29, you map to 1 16th out to infinity. When you're 25, you're 25. This is your base year. But as years continue, your age decreases by a fraction of that base year. So when you're 26, you increase in age 1 half of your age at 25. At 27, you increase 1 fourth your age at 25. When you are 28, you increase 1 eighth your age at 25. At 29, you increase 1 16th your age at 25. Thus, as you age in real time, your actual age will decrease, or should I say, your half-life would decrease. Here we're making what algebraic mathematicians call the surjective map from one set to another. That is, we're putting numbers from one set to another, but not the other way around. Both these sets have properties. The set your age is an infinitely increasing set. The set your half-life is an infinitely decreasing set. But your half-life is decreasing to a value. Its value converges to 0. But that value is 0, it applies to only part of this set. Since your half-life is a rational number, the integer part, 25, stays constant. Only the decimal is converging to a value of 0, which means you set your half-life, the set value of your half-life is converging to 25. Let us show this in a diagram. Here's your age, you're 25 when you're 25. When you're 26, you're 25.5. When you're 27, you're 25.25. When you're 28, you're 25.125. You begin to see what I'm talking about. And I show a few more on the table as we go to the right. You can see that your real age increases. Your half-life age will never go beyond 25. In fact, it will keep getting closer and closer to your original age of 25. Notice also, though, your half-life does converge to 0, and it does it infinitely. It never actually reaches 0. It just tends towards 0. Of course, this means with such a set mapping, you would live infinitely at the age of 25. This could be called immortality, I guess, except no one's figured out how to map such age sets. Oh man, I wish some biologist, geneticist, wizard, scientist booger would do that.